Hello, everyone, and welcome to Open Observability. Today, we're going to talk about the future of observability and, of course, the role that open source has in that future. So, we're going to hear from creators and leading minds of some of the most widely used open source observability projects. And additionally, we'll learn from those who have actually implemented this open source at scale. But the point isn't just to listen in on the conversation. We invite you to participate by joining our dedicated Slack group from the event, which you can find right below me. This would be your chance to ask questions and interact with other attendees and also the event speakers. So you'll notice that there's a channel for each session, so make sure that you're switching channels according to the session that you want to talk about. Also, you should know that this will all be recorded, so you can always come back to watch what you may have missed. And finally, feel free to review our code of conduct, which you can find at Observability.io. So that's enough for me. I'll turn it over to Tomer Levy, Logz.io CEO. Take it away, Tomer.
Good morning, good afternoon. My name is Tomer Levy, and welcome to Open Observability 2020. I'm a software engineer, very much passionate about machine learning and AI, and obviously everything observability from logging to tracing to monitoring. I'm excited to be here, excited to see all the people who are joining this event, our speakers, and the people, the members of the community who are kind of joining today. The idea behind Open Observability was to bring people who created some of the most used open sources around observability, and we can share their vision, share the challenges that they have, where the community is going, and kind of on the other side, share folks that use these open sources today in their companies to share how they use it, what are the challenges, what are they seeing, and then having a goal to create more wide discussion around the vision, the challenges, and how can we progress and advance the industry in the future. So thank you for all the speakers who took the time and energy to share their vision and their experiences. We have people from 7 different countries. I think especially these days when social distancing is so common, bringing folks from all these countries together is exciting. So thank you everyone who joined. Appreciate the time you took. So today I'm going to speak about a topic I'm pretty passionate about, and I'm going to start by looking back and how observability has evolved, and where were we 15 years ago and where are we today. But I think the most important part is kind of share what I believe could be the future, and there is something we can do today to advance the industry, if you will, in the future, and we should start thinking about it today. So I'm going to share some of these ideas, and I would love to interact around them after the session at any time. So the word started with, at least the recent history was around monolith applications running on premises. Usually you'll have kind of dedicated tools for server monitoring and for network monitoring and for application monitoring, and it really came through the organizational design, because you would have the server team, you would have the application team, so every team built their own tool. So if you try to imagine how difficult it is to bring together the knowledge and try to create some kind of intelligence on top of the data, it was almost impossible at that time. The infrastructure was very static, right? Usually on premises, proprietary tools, proprietary formats. Again, bringing together data was pretty hard. VMware, the whole advancement to VMs. So instead of running one application on one server, I can now run multiple VMs on the same server. That's really efficient. But that created some kind of the first evolution of distributed applications, and with that, the evolution of APM is really accelerated, because now I have to look at performance, and now I have to really monitor the application in a different way. And then we started to see the relevant tools kind of emerging. And that was where software really became the business. This was the center. And again, these tools were usually proprietary tools, proprietary data formats, And when you looked across the environment, it was all proprietary, all different formats, and all driving a pretty strong lock-in for customers to move around. And what all of that result in is the inability to look holistically at the system, at the data center, at all the application, and try to extract some kind of a new value that you haven't thought about it, prior to that state. We're now in a new era. Cloud and internet. We're all going to talk about logs and metrics and traces and these three pillars of observability, and that's great. It sounds like we've kind of solved all the problems. We're just going to get all these data together and we won. Obviously, I think we haven't. I think we're only getting started. And even with the best open sources, even when we have, these Jaeger and Skywalker and Zipkin and Grafana and Prometheus and ELK and all of these wonderful open sources that really enable so much innovation, I think there are still gaps. And first, teams have to run more and more of these tools and scale more and more of these tools, and that's pretty hard. But if you think about the level of expertise that engineering team need to have to run high scale production today, they need to know the application layers, they need to know containers, they need to understand networking and security and the cloud and Kubernetes. It's pretty hard, the depth of knowledge and that they have to acquire to be really good at what they do. The day-to-day in operations have evolved from being kind of sysadmins to literally being data scientists. Like, you need to have deep data analytics skills to be able to maneuver enormous amount of data that produce a lot of insights. It's pretty hard, especially when everything is so ephemeral, everything is moving around, scale is going up. And then you ask, okay, so maybe anomaly detection is the tool that is going to help these engineering teams overcome these challenges. And I'm going to argue that most companies today maybe use some portion of anomaly detection, maybe some alerts based on anomaly. That's pretty cool, but it fails too often. And it fails too often because the data is pretty narrow, right? You look at the metrics and you see this, certain number of transactions or number of, error messages. You have very limited lens to look at the data, and that creates a lot of anomaly. That creates a lot of false alarms. And even if you go wider, and I'll ask everyone in the crowd, how many of you have really not like marketing AI, but seriously AI and machine learning that help the engineering team perform their day-to-day, making sure the application is up and running and performing? I'm going to argue that most companies do not have anything that is meaningful. Maybe the Facebook and the Googles of the world have more meaningful capabilities, but I think the majority of the folks do not have anything. So we just imagine the load we have on engineering teams that need to scale and need to make sure their applications are up and running. It's just enormous, and it's going to get worse. This is the reality with more data and more scale. I think to really progress, we have an opportunity to talk about machine intelligence, and I think it's a new era. And we're in a very unique point in time that we can actually enable it in a way which was impossible to do until now. And I'm gonna share my ideas around that. So first, we have more data. If you compare where we are today to 10 years ago, when you have the data so fragmented, for the first time we have the metrics, we have the logs, we have the traces, all of the data together. And that's really powerful because from a lot of data, you can teach a machine to become smarter and get the full context of an event and not just sporadic points in time. For machine learning and intelligence to be effective, you need to have structure. And logs and metrics and traces are a mess. It's really fragmented. I think projects like OpenTelemetry and a couple of other initiatives are critical for creating the advancement we want to create. So I think this is very exciting, and it's something we can do right now. The more structure we can create for these data sets, we can enable innovation, we can enable AI and machine learning to look at the data systematically and produce insights. Um, if you look at where we are today versus even 2 years ago, great, we have the data, we have structure. Now we have access to machine learning for the first time. Machine learning, even those provided by the cloud providers or some other machine learning, there are so many options. So even, smaller companies can take advantage of these capabilities and look at structured data for the first time to extract insights and really help the engineering teams in this sea of data. I'm a big believer in supervised machine learning versus just unsupervised machine learning. And I think when we now take the talent that we have the ability to use accessible machine learning with humans, with DevOps and operations team to supervise and teach machines to look at structured data for the first time in a very effective way. So if we kind of leap a year, 2 years into the future, I think we're going to see something new. It's not just about the data, it's a lot about how we can use machine intelligence to extract insights from that data. So I think we're going to see very, very soon a new generation of early detection, automatic troubleshooting, kind of the next evolution of anomaly detection that can now look at the holistic amount of data and provide insight in a level of accuracy that didn't exist before. And I think if you think about our DevOps and operations team, instead of jumping over endless amount of production issues and small incidents, they will be focused on teaching and classifying these bots that are now doing the day-to-day, the mundane work. And we will constantly just have to teach them and tell them this is right and this is wrong and this is how I do things. This will allow humans to focus on kind of the first time an event happens rather than just on mundane activities. And again, I'm sure some companies have these capabilities, but I think there's an ability to have this data really available for everyone in these capabilities. So if I kind of look into the future, I can definitely see on on the operations channel or wherever team members talk about production, we'll have a couple of bots, and they'll be maybe a little bit different, and they'll listen and they learn and they'll have access to all these data in a structured way, and they can investigate the data in a faster way. Because if you just imagine the amount of data that is produced by machines, who is going to be able to analyze this data faster, a human or a machine? I'm going to argue that a machine will do a much better job, much faster. There is a lot of context that these machines have to understand, the environment and how we're set up and the code. All we have to do is teach them. I think we have an unprecedented opportunity to teach machines how to do this now than we didn't have in the past. And when you look at how on-calls are going to look, I believe the bots are going to wake up at night, and the bots, after seeing 300 incidents and 300 pager duties waiting folks, I think they're going to do a much better job in 95% of the cases, much faster, much more accurate than a human tired at 2 a.m. waking up to take care of something. I think that's really exciting. And if you kind of look at how we progress from a monolith, very, very proprietary data format to where we are today, where open source is so common and open standards are coming into becoming so highly used, I think that we're on the verge of these enhancements in machine learning and AI that for the first time can be effective in our industry. And I actually think there's a lot of room for open source projects that will take these technologies and apply them to standard models and standard data sets. So as you can see, I'm really excited about the future. And at this point in time, I'm a big believer in the need to have standard data. And I think this is a time that the more we can implement these structured data sets. I think the future will be great. So I'm excited about that. Thank you all for joining my session. Thank you all for joining the Open Observability event. I would love to see you later today, and I'm on Slack. So thank you all.
All right. Thank you, Tomer, for kicking us off and setting the stage for today's conversation.